In these sessions, we are going to discuss about the syntax-directed translations and intermediate code generations, where the first concept is syntax-directed definitions. That's an SDD. Syntax-directed definition specifies the values of attribute by associating semantic rules with the grammar protections. For example, an infix to postfix translator might have a protections and rules. So the protections is E implies E plus T, where the semantic rule is E dot code is equal to E dot code and T dot code with the operator plus. So this protections has two non-terminal E and T. The subscriptions of the E is distinguish the occurrence of the E in the protections body from the occurrence of the E as the head. Both E and T have the string value, the attribute code. So the symmetric rule specifies that the string E dot code is formed by the concatenations of the E1 dot code and T1 dot code with the character plus. And the syntax directed translation schemes, it enable frames the fragments called asymmetric actions within the protections bodies, as in E implies E1 plus T. So what are the actions to be performed that can be defined by the syntax directed definitions? So here, what is an actions? The addition. So that can be described with the open brace, that's a print plus. So SDD is a context-free grammar together with attributes and rules. Attributes are associated with the grammar symbols and rules are associated with the protections. If X is a symbols and A is one of its attributes, then we write X dot A to denotes the values of a particular parse tree node label X. So here we can define the non-terminal with their attributes, that's in symbols. Okay, non-terminal is the symbols that can be defined with their attributes. For the evaluations of the expressions means we use a value attributes. For the data type we used a type of that symbol. So here there are two types of attributes: synthesized attribute, inherited attributes. Synthesized attributes for a non-terminal A at the parse node N is defined by the symmetric rule associated with the protections at N. So here the synthesis attribute at the node N is defined only in terms of attribute values at the children of N and at N itself. In this inherited attributes, that is inherited from the parent node to the child node. So the inherited attribute for a non-terminal B at a parse tree node N is defined by the semantic rules associated with the protections at the parent of the N. So at the node N is defined only in terms of attribute values at N's parent, N itself and N's siblings. So example, SDD with the synthesized attribute is the evaluation of the particular expressions E is defined by the right side one expression E1 plus term. So that value to be evaluated for the E left side non-terminal is by the right side value of the non-terminal E1 and T. So the semantic actions for the evaluations of the expressions is E dot val is equal to E1 dot val plus T dot val. So F implies digits means what is the digital X seems available from the symbol table that is stored into the F dot val. That is the corresponding attribute description. So here the SDD involves only the synthesized attributes, so it is also S attributes. So in these evaluations of SDD at the node of a parse tree, so for example all the attributes are synthesized, then we must evaluate the attributes at all of the children's of nodes before we can evaluate the attributes at the node itself. The evaluation orders of syntax directed definitions. Dependency graphs are a useful tool for determining an evaluation orders for the attribute instance in a given parse tree. While an annotated parse tree shows the value of the attribute, how the values to be moved from the root node to next node in this inheritance, and in the S attribute how to be synthesized. So that the directions of the data flow is also described in the annotated parse tree. So the two important classes of SDD are the S attributed and L attributed. The dependency graph depicts the flow of information among the attributes instance in a particular parse tree. An edge from one attribute instance to the another means that the values of the first is needed to compute the second. Edge express constraints implied by the semantic rules. So example, the same example already we discussed, that is an E implies E1 plus T. So it is an actions, the left side expressions value is calculated by the sub expressions E1 and the T. So the E dot val is equal to E1 dot val plus T dot val. So here at every node n labeled E with the children's corresponding to the body of this production. So the synthesis attributes value at the n is computed using the values of the val at the two child labeled E and T. So ordering the evaluation attributes. The dependency graph characteristic the possible orders in which we can evaluate the attributes at the various nodes of the parse tree. If the dependency graph has an edge from the node M to N, then the attribute corresponding to M must be evaluated before the attribute of N. That's all. Thank you.